Hey guys, welcome back to Varnit AI, your go-to channel for the latest in AI development, debates and news. So today we are diving into something truly groundbreaking. Meta has finally released their highly anticipated LLaMA 3.1 with a staggering 45 billion parameter. This model is poised to shake up the entire AI ecosystem, and there's so much to unpack from their research paper and benchmark. So let's get started. So before I start, a brief intro about me. I'm Varnit, the founder of Flourish.ai, an AI consulting and development agency. If your business need help with AI, the link is in the description below.
Today, we're excited to deliver on the long-awaited LLaMA 3.1 405 billion parameter model that we previewed back in April. We're also updating the 8 and 70 billion models with new improved performance and capabilities. The 405 is hands down the largest and most capable open source model that's ever been released. It lands improvements in reasoning, tool use, multilinguality, a larger context window, and much more. And the latest benchmark numbers that we're releasing today exceed what we previewed back in April. So I encourage you to read up on the details that we've shared in our newly published research paper.
Alongside the 405B model, we're releasing an updated collection of pre-trained and instruction-tuned 8B and 70B models to support use cases ranging from enthusiasts and startups to enterprises and research labs. Like the 405B, these new 8 and 70B models offer impressive performance for their size, along with notable new capabilities. Following feedback we heard loud and clear from the community, we've expanded the context window of all of these models to 128K tokens. This enables the model to work with larger code bases or more detailed reference materials. These models have been trained to generate tool calls for a few specific functions, like search, code execution, and mathematical reasoning. Additionally, they support zero-shot tool usage. Improved reasoning enables better decision-making and problem-solving. Updates to our system-level approach make it easier for developers to balance helpfulness with the need for safety.
We've been working closely with partners on this release, and we're excited to share that in addition to running the model locally, you'll now be able to deploy LLaMA 3.1 across partners like AWS, Databricks, NVIDIA, and Grok. And it's all going live today.
At Meta, we believe in the power of open source, and with today's release, we're furthering our commitment to the community. Our new models are being shared under an updated license that allows developers to use the outputs from LLaMA to improve other models. This includes outputs from 405B. We expect synthetic data generation and distillation to be a popular use case that enables new possibilities for creating highly capable smaller models and helping to advance AI research.
Starting today, we're rolling out LLaMA 3.1 to Meta AI users, and we're excited to bring many of the new capabilities that Angela outlined to users across Facebook, Messenger, WhatsApp, and Instagram. With the release of 3.1, we're also taking the next steps towards open source AI becoming the industry standard, continuing on our commitment to a future where greater access to AI models can help ecosystems thrive and solve some of the world's most pressing challenges. We look forward to hearing your feedback and seeing what the developer community will build with.
So guys, that was Meta's announcement video for LLaMA 3.1, and while it's give us a glimpse of what's to come, right? But there's a lot more to explore. So let's dive into the details that they didn't highlight. First up, let's talk about the benchmarks. LLaMA 3.1 45 billion is on the par with state-of-the-art models, and it's even outperforming some heavy hitters in the various categories. For instance, it excels in tool use, multilingual capabilities, and a GSM 8K benchmark. What's even more astonishing is that it surpasses GPT-4 and Cloud 3.5 Sonic in several areas. Now, as you can see, the categories where LLaMA 3.1 outperforms are highlighted. It beats GPT-4 and Cloud 3.5 Sonic in reasoning, scoring an impressive 96.9%. This suggests that LLaMA 3.1's reasoning capabilities might be superior to those models. Now, these benchmarks are a strong indicator of the model's capabilities, but it's crucial to understand the context. LLaMA 3.1 achieves this with a significantly smaller parameter count, 45 billion, compared to GPT-4's rumored 1.8 trillion parameters. So this is a remarkable 4.5 times reduction in size, showcasing Meta's efficiency in model design. But that's not all. Meta also released update for their 8 billion and 70 billion parameter models. These improvements make LLaMA 3.1 the best model in its respective sizes, outperforming competitors like Gemini 2 by Google and Mistral. The 70 billion parameter model, for instance, surpasses Mistral, which uses 8 by 22 billion parameters mixtures of experts and GPT 3.5 Turbo. This isn't just a marginal improvement. LLaMA 3.1 is significantly better across the boards. So when we examine these smaller models, it's clear that LLaMA 3.1, even at 8 billion and 70 billion parameter, perform exceptionally well. The improvement in these models means that for their respective sizes, LLaMA 3.1 is by far the best model you can use. Now let's delve into the human evaluation. These are the crucial because at the end of the day, these models are you're going to use it. People are going to use it, right? The benchmark is impressive, but how do these models perform when evaluated by humans? LLaMA 3.1 hold its ground against state-of-the-art models, winning or tying about 70 to 75% of the time. This is remarkable considering its smaller size and cost efficiency compared to models like GPT-4, which has a whopping 1.8 trillion parameters. The human evaluations show that LLaMA 3.1 perform well in real-world application, which is what truly matters. Now let's talk about architecture. Meta opted for a standard decoder-only transformer model with minor adaptations, focusing on scalability and simplicity. They decided against using a mixture of experts models to maintain training stability. This choice has all clearly paid off, making the model more effective and efficient. It's fascinating to see how these architectural design impact performance and scalability, especially as we move towards more complex AI systems. Now, one of the most exciting aspects of LLaMA 3.1 is its multi-modal capabilities. Meta's research shows that they integrated image, video, and speech recognition into LLaMA 3.1. Although these features are still under development, the initial results are promising. Now, for instance, LLaMA 3.1's vision model performs better than GPT-4 vision in several tasks, and its video understanding capability surpass models like Gemini 1.0 Ultra and GPT-4v. This opens up a plethora of use cases from vision assistant to advanced video analytics. Now let's take a closer look at vision performance. LLaMA 3.1's vision module is designed to handle image recognition tasks effectively. It performs exceptionally well in benchmarks and even surpassing GPT-4 vision in some areas. For example, in the AI2 diagram benchmark, LLaMA 3.1 scores 94.1 compared to GPT-4 vision 78.2. This is a significant improvement and highlights the advancement Meta has made in integrating vision capabilities into their language models. And now moving on to video understanding, LLaMA 3.1 again shows impressive results. The 70 billion parameter model outperformed Gemini 1.0 Ultra, Gemini 1.0 Pro, Gemini 1.5 Pro, GPT-4v, and GPT-4o in various video understanding tasks. While GPT 1.5 Pro might have an edge in long context video understanding, LLaMA 3.1's performance in standard video tasks is remarkable for its size. This opens up new possibilities for video analytics and multimedia applications. Now, LLaMA 3.1 also excels in audio conversations, understanding multiple languages and natural speech. This makes it similar to GPT-4's conversational abilities, but with enhanced language comprehension. This model can handle natural speech and text, understanding different pronunciations and dialects. This is a significant step forward in making AI more accessible and versatile. Another standout feature is LLaMA's 3.1's tool use capabilities. The model can execute complex tasks like analyzing CSV files and plotting graphs thanks to its longer token context length of 128 tokens. For example, it can describe the content of a CSV file and plot data over a time series. This capability is crucial for developing AI systems that can perform a wide range of tasks effectively. Finally, Meta hinted at substantial future improvement. They believe that LLaMA 3.1 is just the beginning and we can expect even more advancement in AI models. They stated that their experience in developing LLaMA 3 suggests that there are many more improvements on the horizon. This means we are only scratching the surface of what's possible with AI. If you are in the US, you can access LLaMA 3.1 directly from Meta. For those in the UK, the only current option is using Grok, an interface platform. However, availability will likely expand soon. So guys, that wraps up for today's deep dive into Meta's LLaMA 3.1. It's clear that this model is a game changer, and we can't wait to see how it evolves. What does it have as compared to other models out there? And so yeah, if you found this video helpful, you can like and subscribe if you want, and I'll see you in the next one. Thank you so much.